Welcome to Easy Maths. This time around, we're going to try out yet another example that has to do with joint variation. And the question before us says, it's given that this thing here, P, something there. We read it as P is or varies jointly as Q and R squared. So it's given that P varies jointly as Q and R squared. When Q is 9, R is 6, and P is 13.5. Find R when P is 43 and Q is 10.5. If R is multiplied by 3 and Q is divided by 3, by what factor is P multiplied? Let's begin. We need to get the general equation, and of course, because given this part here, the general equation therefore will be P is equal to KQR squared. The reason is the proportionality sign or symbol is replaced by equal sign and K. Moving on, we are given the values of Q, R, and P, so replace them over here so that we get the value of K. So here it is. And simplify appropriately, you're going to get the value of K to be 1 over 24. So that the general equation, without the K, or let me say without the unknown K, but with the number 1 over 24, the general equation will be 1 over 20, P is equals 1 over 24 QR squared. So this is a more sensible general equation, since K is now a number, 1 over 24. The first part we were told to find the value of R when P is 43 and Q is 10.5. So we move on to that. P being 43 and Q is 10.5, replace the values in this general equation. And so we're going to have it this particular way and simplify using mathematical operations that students are familiar with at this particular point. So we're going to get 7 over 16, that is 1 over 24 times 10.5. And then you can multiply the other side there and find the square root so that you get the value of R to be 9.91. Hopefully you're not going to have a problem with that. Now we're told if R is multiplied by 3, Q is divided by 3, by what factor is P multiplied? Let's move on to that. And this part is interesting. We're going to find questions of this nature in our national exams as often, many times. And so we need to be keen about this. Now, this is what we do. First of all, write the P that we had at the beginning. P is equals to KQR squared. That one there, write it that way. And then we write now an adjusted P, because this other P isn't the same number as the first one here, because this P has always been influenced by Q and R, but here the Q has been divided by 3, the R has been multiplied by 3. So this P obviously is not the same as the other one there. No wonder I've called it P1, or if you like, an adjusted P. After that, we simplify so that we have the numerals beginning after the equal sign and the unknowns continuing after that. And so I have Q over 3 is simply 1 over 3Q, like this, and then we have 3 squared is 9, the R squared is R squared, K remains K. Now move on to multiply that with 9 so that you have 9 over 3, and then we have KQR squared, KQR squared, and simplify this part here so that you get P1, this number here, that just P is same as 3KQR squared. And with that, an interesting thing is observable from there. This is it. Please notice that the KQR squared we had at the beginning was P. We say that P is equal to KQR squared. And therefore, what we had here is simply P. And so I can replace it. So I have P1 is simply 3P. So the question was, by what factor is P multiplied? Well, the answer is before us here. It is simple. P is multiplied by 3. So the factor is 3. And that brings me to the end of that particular lesson. Please check out for 2 other examples. I hope they're going to be exciting and you'll be able to follow through and as you cement the concepts of joint variation. As always, please like, share, and subscribe. I'd appreciate it.